7th graders, it's time for lesson 2-2, all about ballerinas. 2-2, just kidding. All about slope of a line. What is slope, you say? Probably not, because we've been talking about it a lot in class, but I'll tell you anyhow. The slope of a line, it's the ratio, comparison between two numbers, the change in y, or the rise, to the change in x, the run. It's also known as rise over run. Not run over rise, it has to be rise over run. The change in y, or sometimes it's referred to as that, refers to the amount you move up or down to get from one point to the next. And the change in x refers to the amount you move left or right to get from one point to the next. The trickiest part of this is you're so used to plotting points on a graph, and when you plot an ordered pair, it's x then y. Slope is not plotting an ordered pair. Slope's a ratio of the change, and it's always given as rise over run. So you're actually looking at your vertical movement first with this. Crazy, I know. So a couple different ways to look at slope. Given 2 points, x1, y1, x2, y2, this just means the first ordered pair and the second ordered pair. Don't get concerned about those little numbers there. You can look at this as slope is the rise over the run, the y over the x, or the change in y over the change in x. Or you can actually figure out what y goes up by subtracting the y's and subtracting the x's. Yes, exactly. So here we go. A positive slope, and aren't these cute little pictures? I found these online. I just love them. It's a little race car driver. Positive slope shows the line's going up. Negative slope, the line's going to fall from the left to the right. So you do have to know the difference between the two. Our first objective today is finding the slope from a graph. You're also going to learn how to find it from 2 points and from a table, but we'll start with the graph. Alright, so here's our graph. We want to find the slope of this line. And again, the slope is the change in y over the change in x. Rise over run. It's a ratio of two numbers. So, given this line, I can find the slope of this line by counting from one ordered pair to the next, one solution point to the next, and I'm going to figure out how far up or down I have to go to get from one point to the next. And what people don't like about this is that you don't have to pick two certain points. It's kind of open to pick whichever 2 points on the line you want. And I'll show you variation, I'll show you how it works. So let's say that I pick these 2 points right here, this one and this one. The slope is just how far up then over I go to get from one point to the next. So if I'm here and I'm trying to get up to this point, I would go up 1, 2, 3, and I would go right 2. So 1, 2, 3, 1, 2. That's the rise, that's the run. So I would say that my slope is equal to 3 halves. And you can actually leave it as 3 halves. You're allowed to with slope, because when you graph this, you want it to be in the form of a fraction. That's the next lesson. So if I would have chosen these 2 points here, I would have still had to go up 3 and right 2. So if you chose those, the slope's still the same, right? That's what happens no matter which 2 points you pick. And maybe you're thinking, well, what if I chose those points? If you chose these 2 points, you'd have to go up 3, 6, and right 2, 4. And if you take 6 over 4, doesn't that simplify to 3 halves? Yeah, so you do need to write your slope in simplest form, but you get to leave it as an improper fraction. So when it's improper, if there's a number that will divide into both the numerator and denominator, do that, but then you can leave it as improper. If you can't stand it, you can change it for now, but you'll end up wanting to change it back in the next unit. Or next section, sorry. Now let's say that instead of counting up, you wanted to count down. Because everybody loves a countdown. The final countdown. Anyhow, sorry. I'll try not to be too distracted. It is 5 a.m. right now. That's my coffee time. So if I went from this point to this point, I would end up going down 3 and left 2, right? Which would make it negative 3 over negative 2. What's a negative divided by a negative? Yup, it's positive 3 halves. So even if you chose to go from this point to this point, or from here to here would be down 6, left 4, no matter which 2 points you pick, all of them will simplify to 3 over 2. So slope of this, 3 over 2. That's the ratio of change. All right, let's try another one. Here's the B. Pick any 2 points you want. It doesn't matter which ones. I'm going to start with this one and go from here to here. So to get from this point to this point, the vertical change, the change in the y-axis, I have to go down 2. And the change in the x, I have to go right 1, 2, 3. And right 3 means positive 3, right? So up positive, down negative, right positive, left negative. So that would make the slope of this negative 2/3. Now, if I chose to go from this point to this point, I'd still go down 2, right 3. Down 2, right 3. That's the simplest way to get from one point to the next. If you would have chosen to go up 2 and left 3, you would have 2 over negative 3. Isn't that the same thing? Right? When you have the negative sign in the middle, it can go with either the top or the bottom. It doesn't really matter. So 2 over negative 3 is the same as negative 2 over 3. That's why you usually see it written in the middle, because it can go with either one. So the slope in this one, negative 2/3. If you would have chosen, let's say, to go from here all the way down to here, you'd have to go down 2, 4, 6, and down 6 would make it negative 6. And then to get all the way across here, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm moving 9 to the right, so it would be a positive 9. And if you simplify negative 6/9, wouldn't it simplify to negative 2/3? I know, isn't that cool? Am I the only one that thinks it's cool? I hope not. So any 2 points. All right, a couple more, and I'm not going to go into crazy detail with these ones. We're at the point where now, okay, we can apply it a little bit quicker. So here I only give you 2 points. You're either going to count up or you're going to count down. I don't care which one. I think I'm going to count down. Why not? So from here to here, I have to go down 1, 2, 3, 4, 5, 6. That would make it a negative 6. And then I go right 2. Oops, sorry. So that should be a positive 2. I don't have my whiteout pen at home with me, but it's positive because I went down and then right. So initially, this would look like negative 6 over 2. What's negative 6 over 2? Yeah, it's negative 3. Now, when you're graphing this, later you'll want to put a 1 underneath that. For now, it's okay if it's a whole number to leave it as a whole number. If you absolutely want to put a 1 underneath it because you're used to writing them as improper, you can. It's okay, but you don't have to. All right, last one like this. Then we have, of course, some special cases. This time I'm going to go from here to here. Why not? And you have to go up 2, right 2. Up 2, right 2. No matter what you do, you're going up 2, right 2. So the slope would be up 2, right 2. Which, yeah, that simplifies to a whole number as well. It simplifies to 1. And I could write that as 1 over 1 if I absolutely wanted to. And just in case you're wondering, if I would have went down 2, left 2, that would be a negative 2 over a negative 2. Wouldn't a negative 2 divided by a negative 2 still be a positive 1? Yes, that's why those integer rules are so important. And if you wanted to go down 4, left 4, wouldn't a negative 4 over a negative 4 still give you 1? Yes, I know, it's crazy. All right, special cases. Always there are special cases. So take a look at this. I have just this straight line right here. What do you think the steepness of this little straight line is? Well, I'll reveal that in just a moment. If you're trying to figure out the ratio of the change in x to the change in y for this, to get from one point to the next, let's say we pick this point and this point. How far up do I have to move to get across from that point? 0 is right. And I could move right 3, right? I could also move left 3 and have 0 over negative 3. Either way, what's 0 divided by a number? It's 0. The slope of this is 0. I know, that's it. Slope of nothing. Okay, and it makes sense, doesn't it? If you're like, ooh, let's go on a fun roller coaster ride. It looks like this. It better go really fast, because otherwise that's going to be boring. Unlike the dragster over here. Yeah, this is a vertical line. This has a special little slope to it. Okay, if I'm trying to figure out the ratio of change here, and I'm showing you this way so that if you can't just look at it and know, you still have a way to figure it out. If I'm, let's say, going from this point to this point, my rise would be 3, right? How far over do I have to go? 0. Yep, and if I went down instead, I would go down 3, and I'd have to go over 0. Do you remember the 11th commandment I mentioned in class? Thou shalt not divide by 0. Yeah, this one doesn't have an answer. When something doesn't have an answer in math, we call it undefined. So the slope of a vertical line is undefined. You can't divide by 0. There's not a number that we can use to represent this. Okay, so hopefully graph, we've got the rise over run. Now we'll review a little bit how to find the slope if you're only given 2 points on the graph. So if you're given 2 points, I can't count up and over. I could graph these if I wanted and then count up and over. But a simpler way to do this would just be to take the second y minus the first y, and that gives me the change in y. It tells me what y goes up or down by. And then take the second x minus the first x. I always get the question of, can I take y1 minus y2 instead? It doesn't matter as long as the order is the same. So if you did y1 minus y2, you'd have to do x1 minus x2. You can't do y2 minus y1 and then take x1 minus x2. Hopefully that makes sense. So the 2's, if they're going to go first, they both need to go first. And the 1's both need to go second. And an easy way so that you're not confusing the ordered pairs, just a little visual strategy that I normally use. I just circle and underline. So I usually will circle my y's and underline my x's. And remember, this is your first ordered pair, right? These are both x, y, but because this is my first ordered pair, I would call this x1, y1, because that's the first x and the first y I get. And this I'm going to call x2, y2, because it's the second ordered pair. So the formula just says, if I want to know what this graph, if I were to plot these 2 points, is going up or down by, if I want to know the rate of change, all I need to do is take the second y, 4, minus the first y, 7, over the second x, which is 8, minus the first x, which is 4. And then solve it out. So 4 minus 7, or 4 plus negative 7, is negative 3. And 8 minus 4 is 4. And that can't be simplified anymore. You could, if you want, write the negative sign smack dab in the middle. That would be fine. All right, let's move on to the next one. For letter B, and I'm not going to write x1, y1 above every single one of them, but I am going to underline and use my circles. So in this one here, I want to take the second y minus the first y and divide that by the second x minus the first x. So 4 minus 8, that would be negative 4. 7 minus 1, that's 6. And if you're wondering why I didn't keep change that, well, I'm not trying to take something smaller away from something larger, so that one I just left it. All right, there is a number that goes into 4 and 6. It is 2. So 4 divided by 2 is 2, 6 divided by 2 is 3, and this was negative. You can put the negative with the 2, or you can put it right in the middle. Both mean the same thing. All right, let's keep it going. Or maybe you want to pause and try to do some of these on your own and then play it back after and see if you're right. Just make sure you're writing in pencil so you can fix any errors. All right, y2 minus y1 over x2 minus x1. 4 minus 1 is 3. 2 minus 0 is 2. And I told you that you're allowed to leave it as an improper fraction as long as there's not a number other than 1 that would go into 3 and 2. So we're done with that one. Next, okay, here are my y's, here are my x's. y2 minus y1 over x2 minus x1. 7 minus 7, yep, it's 0. And negative 5 plus negative 7 is negative 12. And if I take 0 divided by a number, it equals 0. So my slope of this one is 0. This isn't the undefined one. The undefined one happens when you try to divide by 0, because thou shalt not divide by 0. All right, letter E. I'm going to circle my y's, underline my x's. y2 minus y1. Be careful, because you're subtracting a negative. It needs to look like that, or maybe you're used to it looking like that. Whatever. And the second x minus the first x. Looks like that. So negative 5 plus positive 3, that gives me negative 2. Negative 3 minus negative 3 or plus positive 3 gives me 0. So with this one, the 0's in the bottom, right? Thou shalt not divide by 0. This would read negative 2 divided by 0. That's not okay. So we're going to write undefined, because that's what the slope is. This is your vertical line one. All right, last but not least of this, I have y2, y1, x2, x1. Let's subtract them. y2 minus y1 over x2 minus x1. The biggest mistake people make with this one is they put the x's over the y's on accident. So don't do that. It's a change in y over the change in x. Y over x. All right, I'm going to add the opposite here. -1 plus -2 is -3. And 2 minus 5, or 2 plus -5, is also -3. And a -3 over -3. Negative divided by negative is a positive. 3 divided by 3 is 1. And you can leave it as that whole number 1. Okay, so far, if I give you a graph, you can find the slope, right? If I give you 2 ordered pairs, you can find the slope. Now I want to be able to give you a table for you to find the slope. So here is how you do it. This is how we do it. We're going to use the same kind of concept that we used when we were just taking y2 minus y1 with your table. Because when you're given a table, these are all your x values, these are all your y values, and these are actually ordered pairs. So when you see this, when x is 1, y is 8, this actually means 1, 8, right? And this would mean 4, 6, and 7, 4, and 10, 2. So these are all ordered pairs. We can find the slope the same exact way. All you're going to do is take, and you can choose any points. It'll work with any, and I'll show you with the first one how that goes. I can take this second y minus the first y. So let's do that. So the second y, again, this would be y1, this would be y2. I have a third y and a fourth y. I'm going to take the second y minus the first y, and then I'm going to take the second x minus the first x. So I know in a table it's written as x over y, but when you're trying to find the slope, you have to write it as rise over run, so you're actually finding the y value first. I know it's crazy. All right, so 6 minus 8, or plus -8, is -2. 4 minus 1 is 3. Your slope is -2/3. Now, just for fun, what if you would have chosen these points instead? This point and this point. If you take the second y2 minus the first y6 over the second x10 minus the first x4, 2 minus 6 would be -4. 10 minus 4 would be 6. And doesn't -4, 6 simplify to -2/3? I know, it's so cool. So choose any 2 points given from your table and take the second minus the first. And bam, you will have your slope. So let's try it with this one. Let's choose the first and last ones just for fun. Alright, so if I take the second y, again it's y over x, minus the first y, over the second x minus the first x, 11 minus 2 is 9, 7 minus 1 is 6, and I told you you can leave it as improper, but not if there's a number that still divides into both. 3 goes into both of those. 3 goes into 9 3 times, and 3 goes into 6 twice. So the slope of that table would be 3/2. Alright, last table, I just wanted to show you that sometimes it's set up vertically instead. I actually prefer this because now it's much easier to see the ordered pair, right? Those are all little ordered pairs. And again, I want the change in y over the change in x. Yes, write that down so you have it somewhere. Normally I keep rewriting it. This time I didn't for some crazy reason. So in this one, here's the first ordered pair, here's the second. I'm going to take y2 minus y1 over x2 minus x1. Be careful when you're subtracting a negative. You can't just write -2 minus 3. It's -2 minus -3. And 4 minus 6, or 4 plus -6, would be -2. And -2 plus 3 would be 1. And when it comes out to a whole number, I usually simplify it to a whole number. If you wanted to leave it as -2 over 1 when we're going to graph it, that would be just fine. Alright, so in summary here, if you're looking at a graph, I found this little picture. It's a little bit kind of blurry, but hopefully on your paper it's a little better. If you see a horizontal line, that means the slope is 0. If you see a vertical line, that's the one where it's undefined. A number that's going up to the right has a positive slope. A number that's going down to the right has a negative slope. Enough about slope. I'll see you tomorrow.